This is SpaceTime, Series 22, Episode 65. Coming up on SpaceTime, planet Earth faces 4 asteroid close encounters in 3 days. The asteroid Ryugu found to be a fragile cosmic rubble pile. And star stuff discovered in Antarctic snow. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have been kept busy with 4 big asteroid encounters with Earth in just 3 days. The first, on August the 26th, occurred when the 110-metre-wide behemoth, classified as 2016 PD-1, flew past the Earth at over 21,000 kilometres per hour at a distance of about 4.3 million kilometres. PD-1 is an Amor-type asteroid. It's a NEO or near-Earth object whose orbit around the Sun lies between the orbits of Earth and Mars, and so is not considered potentially hazardous. That was followed a day later by an encounter with a giant 82-metre-wide boulder known as 2002 JR-100, which flew past the Earth at a blistering speed of almost 31,000 kilometres per hour, significantly faster than PD-1. But while JR-100 didn't get any closer than 7.3 million kilometres from Earth during this encounter, it belongs to what are known as the Aten group of Earth-crossing asteroids, whose orbits intersect with Earth's orbit around the Sun, meaning that it's one well worth keeping a close eye on. Then, just a day later, on August 28th, the Earth had the first of 2 encounters with celestial visitors, as 2019 QS zoomed past, travelling at a breakneck speed of 80,000 kilometres per hour. Luckily, the 60-metre-wide space rock passed the Earth at a relatively safe 2.1 million kilometre distance. The problem is it belongs to another group of near-Earth asteroids known as Apollos, whose orbits are larger than that of Earth's, but are elongated so that they cross Earth's orbit around the Sun, and thus they pose a potential threat to our planet. 2019 QS will be back for another close encounter with planet Earth on November the 30th, 2127. Just hours after 2019 QS made its appearance, the Earth had its biggest encounter in the group when the giant 170-metre-wide 2019 OU-1 swooped past. Flying at a velocity of almost 47,000 kilometres per hour, OU-1 passed our planet at a distance of around 1.3 million kilometres. But OU-1 is another Apollo group asteroid on an Earth-crossing orbit, and it too will be back for another visit, this one around December the 30th, 2080. To get an idea of the sort of damage these space rocks can do, the world-famous 1.2 kilometre wide, 183 metre deep Barringer meteor crater in Arizona was formed about 50,000 years ago by the impact of a relatively small 50 metre wide I-nickel asteroid, which slammed into the ground at around 12.8 kilometres per second, releasing as much energy as a 10 megaton thermonuclear device. So far, astronomers have discovered more than 20,000 near-Earth objects, or NEOs, with new ones now being detected at a rate of around 3 per week. I'm Stuart Gary. This is SpaceTime. Astronomers have concluded that the 850-metre-wide near-Earth asteroid Ryugu is little more than a fragile cosmic rubble pile. The asteroid, located some 300 million kilometres from the Earth, is being orbited by the Japan Aerospace Exploration Agency's Hayabusa 2 spacecraft, which is on a sample return mission to the space rock. Late last year, mission managers began landing a series of small probes on the asteroid's surface. One of those probes was the 10-kilogram German-French Mobile Asteroid Surface Scout Mascot, a lander no bigger than a microwave oven and equipped with an array of scientific instruments. Operated from the German Space Agency's Mission Control Center in Cologne, Mascot successfully descended some 41 meters from its Hayabusa 2 mothership, safely touching down on the asteroid's surface 6 minutes after deployment. Over the course of the next 17 hours, Mascot carried out a series of experiments on various parts of the asteroid, moving amid the large boulders strewn across the asteroid's rugged surface. Detailed observations of the descent from Mascot's cameras show Ryugu's surface to be composed of a fragile rubble pile made up of 2 different, almost black types of rock with little internal cohesion. A report in the journal Science suggests that if Ryugu or another similar asteroid were to come dangerously close to the Earth and it was decided to make an attempt to try and divert it, an enormous amount of care would be needed. You see, any attempt resulting in an impact with great force would simply cause the entire asteroid, weighing approximately 500 million tons, to simply break apart into numerous fragments. So, instead of having a single asteroid targeting the Earth, there would be hundreds, possibly even thousands of smaller individual fragments, weighing several tons each, which would impact the Earth, peppering the surface over a wide area. The early observations by Mascot have shown that Ryugu is very similar to carbonaceous meteorites found on Earth, which date back some 4.5 billion years. With an average density of just 1.2 grams per cubic centimetre, Ryugu is only slightly heavier than water ice. But the asteroid is made up of numerous pieces of rock of different sizes. This means that much of its volume must be traversed by cavities, which probably makes this diamond-shaped body extremely fragile. As Mascot moved across the asteroid's surface, scientists detected two specific types of rock, but interestingly, no dust. The boulders seen in images acquired by the camera during Mascot's descent and on the surface are mostly dark, measuring between 10 centimetres and a metre across. Although most of them are very rough and angular, there were some smooth ones there as well. Scientists noticed that boulders with level fractured surfaces and sharp edges appear to be slightly lighter in colour than those with more irregular, cauliflower-like and partially crumbly surfaces. On average, Ryugu reflects only 4.5% of the light that reaches it. That's comparable with charcoal, and makes Ryugu among the darkest objects in the solar system. Mascot's camera system was equipped with light-emitting diodes, allowing it to image in both daylight and at night. The LEDs illuminating the immediate surroundings in different, clearly defined colour wavelengths in visible light and near-infrared. This allowed them to record the reflective behaviour of their environment in different spectral channels. The two types of rock observed are distributed approximately equally over Ryugu's surface. Now this suggests two possible origins. It could be that Ryugu was formed following a collision between two separate bodies made up of different materials. As a result of this collision, these two bodies broke apart before the fragments came together again under the influence of their combined gravity to form a new body made up of the two different types of progenitor rock. Now, alternatively, Ryugu could be the remnant of a single body whose inner zones originally had different temperature and pressure conditions, causing differentiation and resulting in the ultimate formation of the two different rock types. As well as the rocks and boulders strewn across the surface, scientists were also surprised by the lack of dust on Ryugu's surface, despite the region being littered with boulders. Lots of dust should be present due to the bombardment of the asteroid by micrometeorites over billions of years and the eroding, weathering effect that causes. However, the asteroid does have extremely low gravity, just 1/60th that experienced on the Earth's surface. So it's possible the dust simply escaped back into space. Alternatively, it may have disappeared into cavities in the asteroid. All this gives a great indication of the complex geophysical processes occurring on the surface of this small world. Mascot scientists originally thought Ryugu was similar to two famous meteorites which fell to Earth in 1969, one the Allende meteorite, which fell in Mexico, and the other the Murchison meteorite, which fell in the Australian state of Victoria. However, those meteorites contain very few bright particles, probably due to the weathering effect of the crystal grid in these minerals. Ryugu's cauliflower-like rocks do contain some bright inclusions, and that suggests the asteroid probably has more in common with meteorites from Tagish Lake. On January the 18th in the year 2000, hundreds of small meteorites rained down over the Earth following the explosion of a large fireball over Canada, with numerous fragments found embedded in ice on a frozen lake. These were very rare stony meteorites from what's referred to as the Ci chondrite class. The C stands for carbon, and the ice for the similarity with the Ovuna meteorite found in Tanzania. These are now known to be among the oldest and most primitive components of our solar system, remnants of the very first solid bodies to be formed out of the primordial solar nebula. Ryugu is a near-Earth object, or NEO, that is, an asteroid or comet that comes close to or intersects with Earth's orbit. In some cases, these might be on a collision course with the Earth. Ryugu's orbit around the Sun is almost coplanar to that of Earth and approaches it at an angle of 5.9 degrees to within a distance of approximately 100,000 kilometres. Ryugu will never come within the immediate vicinity of Earth, but knowing the properties of bodies like Ryugu is of great importance when it comes to assessing how such near-Earth objects could be dealt with in the future. While the Mascot submission was being completed, Hayabusa 2 carried out numerous maneuvers, mapped the asteroid in high resolution, and collected samples from various parts of the asteroid's surface for return to Earth. These samples have now been sealed in a special transport container with a return journey to Earth expected to start in December. The sample container will then be ejected as Hayabusa 2 flies past the Earth, the container parachuting down onto the Woomera rocket range in the South Australian outback next year. I'm Stuart Gary. You're listening to Space Time. Scientists have discovered supernova remnants from a long-dead star in Antarctic snow. A report in the journal Physical Review Letters claims the remnants in the form of the rare isotope iron-60 were originally forged in a nearby star as it exploded as a supernova millions of years ago, destroying the progenitor star and briefly outshining the entire galaxy. A massive explosion showered the surrounding space with debris, forming a supernova remnant and a huge interstellar dust cloud. Later, the Sun and Solar System, including Earth, began to pass through this dust cloud, resulting in some of the debris dust, including the iron-60, falling down onto the Earth. Researchers discovered the iron-60 in 500 kilograms of fresh Antarctic snow samples. The snow had all fallen onto the frozen continent within the last 20 years. The authors then melted the snow and discovered the iron-60 remnants embedded in it. After eliminating possible terrestrial sources, such as nuclear power plants and nuclear weapons testing, the researchers concluded the isotopes must have come from interstellar dust, where it was forged by a nearby supernova that produced clouds of gas and dust enriched with radioisotopes. The authors speculate that as the solar system passed through such clouds in the past, this dust fell onto Earth's surface, where detectable concentrations were able to accumulate. One of the study's authors, Dominic Knoll from the Australian National University, says the findings could help scientists deduce the structure and origin of interstellar dust clouds, allowing them to more precisely reveal the history of the solar system's interactions with its interstellar environment.
What we did is we analyzed 500 kilograms of Arctic snow. We collected it near the research station in Antarctica, the Conan Research Station, and this was then shipped from Antarctica to South Africa and from South Africa to Germany. And when we got it then in Munich and processed the snow, it came frozen to Germany. Then we melted it and filtered it. And then after some chemistry with the filters in the water, we analyzed the iron fraction and found iron-60 in it.
What's the significance of iron-60?
Iron-60 is not produced on Earth in large quantities. So you can either produce them in accelerators or nuclear reactors, nuclear bombs. But the amount of iron-60 that is produced there is quite tiny. So usually you don't find it on Earth. And iron-60 is produced in stars and by cosmic rays. So when you find iron-60 on Earth, it's basically already an indication for an extraterrestrial process, either cosmic ray production within our solar system or a stellar explosion outside of our solar system.
The universe is a very dusty place. Right now we're going through a dust cloud. I think it's called the local cloud, isn't it? And we think that could be the result of some sort of supernova event in the past. Is that the sort of origins you're looking at regarding these particular isotopes that you found?
Yeah. So the question is, when you find this iron-60, the question is always, where does it come from? And by ruling out all the other possible production ways, then you go to supernovae. And then the question is, when you find it right now, where around our solar system is this iron-60 right at the moment? Because when we find it now, then it must be around us. And currently we are in the local interstellar cloud, and there are theories behind that this local interstellar cloud was produced in a region where several supernovae went off, and therefore we, as a working hypothesis, started investigating the local interstellar cloud a little bit further, and then we thought, okay, if this is true, that the local interstellar cloud itself was formed in a region where lots of stellar explosions happened, then there must be iron-60 still in there. And that's why we were looking at recent material and tried to find iron-60, and we did.
What do we know about the cloud we're going through now? We've been in this cloud for a while, haven't we?
Yeah, so we've been in this cloud for several 10,000 years, and we still will be in this cloud for a few hundred years, a few thousand years. That's not entirely clear. But we are in this cloud, and we know that this cloud is a little bit denser than the other interstellar medium around us. And we know that there is a significant amount of dust in this cloud. So there is like a natural explanation that you might find iron-60 in there. But of course, only by measuring iron-60 doesn't really mean that this is true. But it somehow points to that the local interstellar cloud might be the source.
Things like the helioshock and the heliopause aren't enough to prevent this Iron 60, this cosmic dust, from reaching us.
Yeah, usually when you look at supernovae, you have direct ejecta of the supernovae, which is plasma, and this is moving fast forward with a lot of generating a lot of pressure. But this is highly charged, and particles in there, they are relatively light. So therefore, in the end, what comes into play is the magnetic field imposed by the sun, and then all the plasma is basically, it cannot really enter our solar system because it's deflected by the magnetic field. But once the iron 60, for example, is incorporated into dust grains after these very tiny grains formed, then the mass gets higher and the average charge is lower. So the mass to charge ratio is in the end higher, which means they're not as easy deflected as the plasma itself. So they can then penetrate into our solar system.
The Antarctic snow that you melted, was this just surface snow or did you dig down very deep?
No, it was really surface snow. So we estimate that it's not older than 20 years from now. And that's the spectacular thing about it, because it's right now, the supernova dust is basically raining down onto Earth, and we can find it right now.
Are you looking at digging deeper, looking at core samples?
Yeah, that's what we propose. This would be the next step, to look at deeper samples from several 10,000 to 100,000 years ago, and then to see if there is a sharp increase at a certain time of iron 60, and then this would be a clear indication that we entered basically a region around our solar system somewhere where the density of iron 60 is higher, and if this would coincide with the estimated entry into the local interstellar cloud, this would be a really strong argument for the local interstellar cloud as source.
That's Dominic Knoll from the Australian National University. And this is SpaceTime. I'm Stuart Gary. The SpaceX CRS-18 Dragon capsule has returned to Earth safely, splashing down in the North Pacific Ocean. The spacecraft had been docked to the International Space Station's Harmony module for a month, following its launch aboard a Falcon 9 rocket from the Cape Canaveral Air Force Base in Florida. For its return journey, the Dragon carried more than 1,224 kilograms of returned scientific experiments and equipment. It splashed down some 483 kilometers southwest of Long Beach, California. Included in the return manifest were experiments looking at the effects of rock-eating microorganisms in microgravity, research on how moss grows in space as part of studies on plant growth in microgravity, a better understanding of silica morphology and the relationship between its structure and properties, an Alzheimer's study looking at the properties of amyloid fibrils, a fiber optics manufacturing investigation, and a study testing flexible fuel tanks, as well as research into growing crystals in microgravity, the effects of weightlessness on wound healing, and the use of artificial intelligence in space. The United States has successfully test-fired its new Arrow 3 anti-ballistic missile system. The Israeli-developed hypersonic rockets designed to intercept incoming ballistic missiles or orbiting spacecraft outside the planet's atmosphere. A series of tests were undertaken jointly by the United States and Israel in Alaska. The Arrow 3 uses a divert motor to dramatically switch directions, allowing it to pivot in flight to line up approaching missiles and intercept them, executing precise hits at unprecedented altitudes and speeds. SpaceX has successfully placed the new Israeli telecommunications satellite into geostationary orbit. The Spacecom Amos 17 took off under leaden skies aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Air Force Base in Florida.
Stage 2, pressing for flight.
LD is go for launch.
Stage 1, pressing for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
Vehicle is pitching downrange.
AVI power and telemetry nominal.
Vehicle is supersonic. Vehicle has reached maximum aerodynamic pressure.
You've heard the call out. We're through the region of maximum aerodynamic pressure. Vehicle going supersonic as we leave the denser parts of the lower Earth's atmosphere. Falcon 9 trajectory looks good. All 9 Merlin engines are at power. Everything looking good for Falcon 9. We're heading due east from Cape Canaveral, headed to the first of 2 orbits planned for today. First stage shutdown is planned for about T plus 2 minutes, 45 seconds. We won't be recovering the first stage today, so that leaves more propellant to burn to achieve the required orbit for the satellite. If you compare that to last week's CRS-18 resupply flight to the space station, on that mission the first stage shut down almost half a minute sooner than today. We needed to reserve enough propellant to be able to turn the first stage and return it all the way back to the launch site. Now coming up quickly in 20 seconds, a sequence of events: main engine cutoff, the 9 main engines shut down, stage separation, and then ignition of the second stage engine.
AVI stage separation confirmed.
We've had successful ignition of the second stage engine. The Merlin Vacuum D engine is up at power. Turbine speed looks good. First stage has completed its mission. It's falling back to Earth. As we said, we won't recover it.
AVI fairing separation confirmed.
The second stage has separated the payload fairing around the Amos-17 spacecraft as we're now in the vacuum of space. Right now, Merlin vacuum engine continues to be on power. Trajectory looks good. Stage 2 is right in the middle of the predicted path. Avionics reports their systems are nominal. We are go on Falcon 9 carrying Amos-17 to the parking orbit, the first of 2 orbits for today.
The 6,500 kilogram Amos-17 replaces a satellite which blew up on a launch attempt last year. Built by Boeing using a 702 digital processor platform, the Amos-17 is equipped with Ka, Ku and C-band transponders using both regional beams and high-throughput spot beams, covering a footprint extending over Africa, the Middle East and Europe. The new spacecraft will have an operational life of at least 19 years. An all-disused European Space Agency Ariane 4 rocket booster has suddenly exploded in orbit. The blast was detected by the 18th US Air Force Outer Space Control Squadron, which reported the detection of 7 major debris fragments. It's understood the booster, which was actually a third-stage segment of an Ariane 4, exploded on its own rather than due to a collision with other objects. The booster was used in August 1992, taking 3 satellites into orbit, including the US-French Topax Poseidon, the South Korean Kitsat-1, and France's S-80T. Prior to the explosion, the discarded rocket stage had been quietly orbiting the Earth for nearly 27 years, at an altitude ranging from 1,404 to 1,296 kilometers. The 59-meter-tall Ariane 4 was the backbone of the Arianespace medium lift capability between 1988 and 2003. That's when it was replaced by the heavy-lift Ariane 5 and eventually the medium-lift Russian Soyuz ST. Japan is looking into creating its own military space wing. The move would bring it in line with Russia and China, which already operate strong military space forces, and with the United States, which announced similar plans earlier this year. Tokyo is already working on a ground-based space tracking system using highly sensitive radar and optical telescopes. That's expected to be operational by 2023. The new military unit's main task will involve monitoring space debris as well as threats of attacks or interference by other foreign space-based forces. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have for the first time grown miniature brains from human stem cells that produce brainwaves. A report in the journal Cell Stem Cell claims the team grew hundreds of pea-sized brains from stem cells for 10 months and monitored their neural activities using electrodes. The organoids started producing bursts of brainwaves after about 2 months. These early signals were sparse and had the same frequency, similar to what scientists see in the brains of preterm babies. But as the mini-brains continued to grow, they began producing brainwaves at different frequencies, and the signals appeared more regularly, suggesting the neurons were developing more connections and creating a neural network. New satellite data and images from the International Space Station show that the disastrous Amazon rainforest wildfires are continuing to spread. The crew aboard the orbiting outpost are reporting smoke from the fires is visible for thousands of kilometers. On the ground, strong winds are known to be carrying the smoke plumes across land and sea, causing day to turn into night in many Brazilian towns and cities. Data from the Earth-orbiting Copernicus monitoring system shows the smoke from the wildfires has even travelled as far as the Atlantic coast. Brazil's National Institute for Space Research says over 76,000 fires are now burning across the Brazilian Amazon. That's an increase of more than 80% over this time last year. Copernicus Sentinel-3 data from the European Space Agency has helped detect almost 4,000 fires in the last month alone. That compares to just 1,110 fires during the same period last year. The Amazon rainforest covers vast regions of Brazil, Colombia, Venezuela, Ecuador, French Guiana and Suriname, as well as parts of Peru, Bolivia, Paraguay and Argentina, all of which have been affected by the fires. Of course, the tragedy is the Amazon basin is home to millions of plants and animal species. It's one of the most biologically diverse regions on Earth, often referred to as the lungs of the world, and credited with producing an estimated 20% of the planet's oxygen. Scientists say that while these fires are common during the dry season, which runs from July to October, this year's event is simply unlike any other, 4 times the normal amount, and being caused primarily by loggers and by deforestation for agriculture. Rising global temperatures due to climate change are also thought to be making the region more susceptible to fire. More than 90,000 banking customers have had their details and personal data exposed after PayID was breached through Credit Union Australia in the second major attack on the payment management system in recent months. Payments provider Qscale, which is partnered with more than 120 banks and financial institutions across Australia and overseas, says the breach has infected most organisations using PayID. PayID allows banking customers to use their phone number or email address to identify their account details in real-time payments instead of having to remember their BSB and account number. The northern white rhino is about to become extinct, with only 2 individual members of the entire species now left alive worldwide, and both of those are females. The majestic beasts have been hunted to extinction by poachers, who've slaughtered the animals simply for their iconic horns, which are considered an aphrodisiac in traditional Chinese medicine, a claim proved to be completely wrong and without any supporting scientific evidence. In a last-ditch effort to try and save the northern white rhino species, scientists in Kenya have successfully harvested eggs from these 2 surviving female rhinos. Researchers hope the eggs can now be artificially inseminated with frozen sperm from a northern white rhino bull, and in the near future the embryo will be transferred to a southern white rhino surrogate mother. A new study suggests that caring for a pet can help you maintain a healthy heart. The findings, reported in the journal Mayo Clinic Proceedings, examine the association of pet adoption with cardiovascular disease risk factors and health. The study compared the cardiovascular health scores of pet owners with those who did not have pets. It found that people who owned a pet were more likely to have greater physical activity, better diets and better sugar levels, with the greatest benefits rewarding those who owned a dog, independent of the owner's age, sex or education standard. Scientists say the study demonstrates that having a dog may prompt owners to go out, move around more, and play with their dog regularly. It looks like Apple could be revealing their latest smartphone on September the 10th. The rumours are based on a screenshot uncovered in a beta iOS 13 operating system calendar app, with the date set to Tuesday the 10th of September, with the caption "Hold for release." Alex Horach from whistleout.com.au says the new iPhones are rumoured to include several new features.
We don't know much for certain about the iPhone 11, including the name. So we're expecting 3 new iPhones again, and they should be quite similar to what we've seen this year. 2 pricier iPhones, which are being kind of like pitched as maybe like iPhone 11 Pro and iPhone 11 Pro Max, and they'd be direct successors to the iPhone 10 and iPhone 10 Max. The biggest changes are meant to be that they'll have 3 rear-facing cameras on the back, up from 2, with the addition of a wide-angle lens.
Yeah, it's a really ugly-looking setup too that they've got there.
Yeah, it's not great, but I mean, you're not often looking at the back of your phone, so I don't think it matters too much. And it's meant to, so you'll be able to like zoom out from your photos as well as zoom in. And there's rumors that it should also improve low light photography. And there's also like murmurs that they might support the Apple Pencil, kind of like the S10 on the Galaxy Note 10. Then there's also a cheaper iPhone 11. It might be called the iPhone 11R or maybe just the iPhone 11. And that's meant to be a direct successor to the iPhone 10R. So, it'll be aluminium rather than stainless steel. It'll have a lower resolution display, that's LCD rather than OLED. So that means it won't go quite as dark and have a lower contrast ratio, but Apple LCD displays have typically looked pretty great anyway. On the back, we're expecting to see 2 cameras rather than 3. It's just your standard primary lens and a zoom lens.
Well, the big downside for Apple, of course, with this phone is it won't have 5G capabilities, and that all comes down to problems in actually getting the chips 5G compatible.
Yeah, that's correct. It's not We're not expecting to see a 5G iPhone until 2020, and that's partly due to a dispute Apple had with Qualcomm. But I believe that's been resolved now. I guess we'll see how it pans out in terms of how punctual Apple is with getting a 5G smartphone to market. But at the same time, 5G is very limited, both in Australia and globally right now. So Telstra is the only telco with very publicly live 5G network. Optus is taking pre-orders for the Galaxy Note 10 5G, but those won't start arriving until September 20th. And even Vodafone isn't expected to launch a 5G network until 2020. But when you look at the Telstra and Optus coverage maps, there's just not much 5G. And early 5G phones still have problems. Battery, since every 5G phone has a dedicated modem that isn't part of the chipset yet, battery drain is a bit more pronounced than when you connect it to a 4G network. And since there's quite limited 5G coverage, these 5G phones are always looking for 5G, and that puts another demand on the battery. So when I've been testing a 5G phone in a 5G area, Apple has never been a company that wants to be first for the sake of being first. Apple always tends to be happy to let someone like Samsung take the glory of having the first 5G smartphone. Apple seems to be the kind of company that would rather take its time and kind of avoid those early adopter issues, even if it does mean being late to the party.
That's Alex Horosh from whistleout.com.au. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favorite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.